Yeah, welcome to this lesson. And in this lesson, we'll be treating bond properties and molecular geometry. So, bond property such as characteristics are properties such as bond length, bond energy, and bond angle. And these properties they tend to play crucial roles in determining the molecular geometry of atoms. So, of atoms and molecules rather. So, in the spatial arrangement of atoms in a molecule affects the physical and chemical properties. So we're talking about the molecular geometry. So this molecular geometry tends to affect the physical and chemical properties of atoms, including their polarity, their reactivity, and phases of matter, as well as color. So let's see. Focusing on bond length. Bond length is that distance between nuclei of two bonded atoms, which is what I was trying to explain when I was talking in the previous lesson. I was talking about fat people and slim people standing close side by side, and saying that the distance between their hearts for fat people standing beside themselves would be more. So, in this sense, now we're talking about long distance and short distance relationship in that same distance, in that same idea. So, as distance between the nucleus of one species or one atom and another atom, as it increases, it tends to affect the strength of the bond. It tends to affect the strength of the bond. Farther distance form lead to weaker bonds, while shorter distance leads to stronger bonds. So this is an idea that you should get to memorize very well, because it's kind of makes sense physically. Longer distance would lead to weaker bonds, while shorter distance will lead to stronger bonds. So let's see bond angle. So bond angle now is another concept that we'll be talking about, and it is the angle that is formed between three atoms. Yeah, the angle that is formed between three atoms, where we have a center atom and the other two atoms. So it is the angle that is formed between three atoms across at least two bonds. Across at least two bonds. So bond angle is the angle formed between three atoms across at least two bonds. So when we're talking about bond angle, there need to be three atoms, and these three atoms need to have at least two bonds. So it is influenced by hybridization of the central atom and also the repulsion between electron pairs, as described in the valence shell electron pair theory or electron pair repulsion theory. So when we go into this valence shell electron pair repulsion theory, we would understand this in detail. So the thing we're trying to talk about is just in this level is just bond angle and knowing how it happens. So from this diagram, we are seeing when you talk about bonding angle, I mentioned here that we would know that it is influenced by the hybridization, the type of hybridization of the center atom. Another thing that affects the bond angle is also the repulsion between the electron pairs. So in every combination of three atoms, or in every bonding, there is always different categories of electrons. Two categories basically, two categories of electrons, and the categories of electrons are the bonding pair and the non-bonding pair. And these non-bonding pairs are called the lone pair of electrons. They are usually the non-bonding pair. So there are two types of electrons in every bond or bonded species. There is usually the bonding pair and the non-bonding pair. So the repulsion between these different categories are what lead to different bond angles. So later on we'll discuss in more details what can lead to these stuffs. So molecular geometry. So when you talk about molecular geometry, we're talking about the three-dimensional arrangement of atoms within a molecule. And we have stuffs like linear, trigonal, planar, tetrahedral, trigonal, bipyramidal, octahedral, and so on. So there are many different forms of molecular geometry. So depending on the different number of atoms, we would have different geometries, and depending on also the number of lone pair of electrons, would also have different geometry. So this will be discussed more in details when we go into molecular geometry and also bonding. There's a topic later on in this series. So let's see. Um, as I said, the geometry is determined by the number of bonding pairs and also the lone pairs of electrons around the center atom. So the theory now will be summarizing this Vesper's theory, this VSEPR's theory, which is the valence shell electron pair repulsion theory. So the theory is used to predict the molecular geometry based on the number of bonding and lone pair of electrons. So these electron pairs repel each other, and arrange themselves to minimize the repulsion. So the whole idea of this valence shell electron pair repulsion theory is just trying to say that when you have an electron, when you have pairs of electrons in an atom or in a molecule, that the shape of the way these electrons or these atoms would arrange themselves in space would be dependent on the presence of bonding pair and non-bonding pairs. So the presence of bonding pairs and non-bonding pairs is going to be what would determine the molecular structure of or the molecular geometry of the molecule in question. So when we go into detail, I think that will be when this diagram will be much clearer. So, but this diagram is trying to show here we have three atoms. There's always going to be three atoms when you're talking about geometry. You have three atoms and they have a linear shape. So when there's a single lone pair of electrons, the shape would be skewed. When we have two lone pairs of electrons, the shape will be further skewed. So the same thing applies here and also here. So later on we'll be seeing how this applies. So you can see how it happens here when we have a single lone pair for the same number of atoms, single lone pair. The shape was skewed here. The angle now here, the angle was 120, but now the angle now became 120. The angle was 180 here. Now the angle is 120. The same number of atoms, 1, 2, 3. Here too we also have 1, 2, 3. But here, because of there was no lone pair of electrons, we had a 180-degree spread. So but here, the same number of atoms, we have a 120 degree. So this lone pair tends to force these ones to bend themselves because it wants to adjust itself to take comfortable, like to repel these atoms, wants to repel the electrons on these atoms, leading to a bend. So the same thing now, the same number of atoms is what is here. We have 1, 2, 3 here on this side, 1, 2, 3 here. So but now on this side now we are seeing that there are two lone pairs of electrons. So these two lone pairs of electrons will first try to distance themselves from themselves. Then next they will shrink these other ones. So this angle here is 109.5. So here we have 109.5 as the angle, the bond angle between the same three atoms. So we have the same three atoms here, here, and also here. But now the angles are different because of the presence of these lone pairs of electrons. So we will discuss it better in details when we go to Vesper's theory in full. So polarity now is a species that also is a kind of characteristic rather that also influences the molecular geometry. So if dipoles of individual bonds do not cancel each other due to asymmetric shape, the molecule is said to be polar. So what is this meaning? They're trying to say that when you have a molecule that its electronegativity on both sides or both ends of a particular bond is different, as they call a dipole, when we have two charged ends of a particular molecule and the energy does not cancel out, the negativity does not cancel out on both sides, you can tell that that particular molecule is said to be polar. So this affects the solubility, the melting point, and also the boiling point, as well as the internal molecular attractions of these molecules. So we'll talk about bond properties and molecular geometry. So to conclude, the properties of bonds and geometry of molecules are foundational concepts in understanding molecular behavior. They help to predict the structure, reactivity, and physical properties of substance. So in the next lesson, we'll be treating hybridization and shapes of molecules. So that will be all for this lesson. Goodbye.